Free body diagram is the first step in solving any mechanics problem. So let's get this concept clear as soon as we can. So to understand the concept of free body diagram, imagine that I'm doing my pull-up exercise in the morning, and that's me, and say I'm about 150 pounds, so it's gonna act downwards like this, and then I'm doing my pull-up exercise like this. Now free body, the concept of free body, as it says, you free the body first. So now I am going to release my hand from that place I'm holding the bar. So that's me, 150 pounds. Now when you release, now you release it, so now I will drop down to the floor at a speed of 32, not the speed, at acceleration of 32 feet per second square, or 9.8 meter per second square, whatever unit you're familiar with. So I'll start to go down. Now remember, the first thing, everything is static here, so you are making imbalance by freeing the body. So you have to balance it now by applying some opposite forces and moments, whatever that is applicable. In this case, is the tension in my hands that will balance me. So the concept of free body, first you free the body. So we free the body right here. Depending on the situation, analysis will be interested in free in different places. In this case, I release my hand from here. So now I have to, and there's this external load, my body is 150 pounds going downwards, and then to balance that I have to apply two different forces. So that completes the free body diagram. Now there are 5 different connections or support that you have. So one is just, I have shown you my pull-up exercise. It could be as a flexible rope, cable, chain, anything. Let's say this lift is pulling something very heavy, some weight, 1,000 pounds or something like that. So when you free, let's say we are analyzing this chain and we are going to free it right here. So if you free it right here, whatever it is pulling is going to start to go down. So we have to balance that. So to complete the free body diagram, you show that force as well as you do that balancing force. So that completes the free body diagram for this connection type 1, which is the flexible rope or cable. Now there could be a roller, some kind of roller support. So this chair is supported by rollers, and it doesn't have any friction, any frictionless place or frictionless reaction. So for this, you have the chair weight coming down this way. So now let's say we're going to draw the free body for one of these rollers. So we release this roller header, we take the support away. It was supported by the ground here at the roller. Let's say we take one of these support or the support away from the roller underneath, so it start to go down. So then we're making it imbalance, as the frictionless surface will have the exact perpendicular direction reaction force that will balance this body. So in this particular scenario, simply the free body would be, so the weight of this person or chair, and then a reaction force like this for one of the leg. Now if it's in an inclined surface like this, then again the reaction would be perpendicular to the surface, not in the vertical direction. And then a smooth surface is actually same as the rollers. Again, this will have exactly, let's say we're trying to analyze this player, it's going to be exactly perpendicular. The reaction will be exactly perpendicular, even though he's kind of in that angle. It doesn't matter. For this sliding or snow sliding situation also, it's not going to be exactly perpendicular. It's not vertical, it's going to be perpendicular to the surface, not vertical. So it's going to be a little bit towards that heel. So surface, smooth surface, exactly perpendicular reaction. Now for this, there is four type of connection, which is called pinned, hinge, or knife edge, or rough surface. Look at this table, work table, where you don't want the work table to move around. Also, you don't want to attach this to the ground. So if you, for the analysis purpose, if we release this from one of these leg, so the weight of the table will go down this way, and then because we are taking this support away, so then we have to balance that force by applying another support force. However, it's a rough surface, so there will be some resistance coming. If you try to push this way, it will have a resistance in this direction. So for the hinge connection, we'll also have both components, the X and Y and X components. So if you draw the free body for this pinned hinge type of a situation, you have to show all the external load, also the the reaction forces, Y component and X component. So F, Y, F, X. Now in this scenario only Fy, this scenario only Fy, this scenario only tension in the rope. In the final scenario is a fixed connection, where let's say we're trying to see what's going on at the base of this. Generally this thing breaks right here. So if we free this body here for the analysis purpose, you realize the weight of this piece will try to cause a moment like this direction. So we have to apply a counterclockwise moment as well. So you will have both y-axis force and then the x-axis reaction force. So reaction at x direction, reaction at y direction, and also some counterclockwise moments that for this category 5 type of connection or support. So one note, regardless of the direction that you think this reaction will have, you always assume positive direction. So always you assume as soon as you release it, you try to balance the body. The balancing would be always X direction positive direction, Y direction upward direction positive, and counterclockwise positive direction. So this is the convention you'll be using for it will help a lot in terms of thinking, because you're not just drawing free body. This is actually the first step of solving any mechanics problem. There are a couple of steps coming next, which I will be explaining in next videos.